All right, one more go. Here we go. As soon as it starts recording. All right, one more. Here we go. Let's see. So we're gonna go back and forth a little bit between slides and whiteboard on this one because this set of slides is going to get us some more fun with UML. So if you remember UML from last semester, and if you really liked UML from last semester, you're going to love this lecture. It's going to be great. If you are not a fan of UML, you're just going to have to sit through it. Okay, so but UML is really fun for me. I'm a visual person, so when I think of a system designed using a visual modeling like UML, Unified Modeling Language, it really helps me understand how a system is designed to be able to see how the parts interact. Okay, so basically, how do we think in objects is if we can think about how to design our systems using class diagrams and how to solve problems then with an object-oriented paradigm using class diagrams, then we can write our systems in Java, in Python, in C#, in lots of different languages without having to be tied to the language that it may have been initially developed in. Okay? All right. So let's talk about some of this class stuff. All right, so we are going to have this idea of a class implementation. It's going to act like a black box that our users don't need to see, but what's inside of the class we can show. We can kind of say this is what's inside, but we don't have to show them all the details if we show some of the aspects of a class. Okay. For example, we had a class like the loan class where we might have some some data fields, right? Annual interest rate, number of years, how much is the loan for, what date was the loan created. Now notice that in what we have here is we have this little minus sign in front of it. That means private. That means that no one can see it, okay, except for the class itself, okay? But this is a way that we can say, hey, this is a thing that's in there. This is a data field that's in there, but you won't be able to access it directly. You're going to need to access it through a get method or a set method. Then down in the second section, we have all the methods. The plus sign means public, means everyone can see it. Okay, and we give kind of a little description of what it's supposed to do. Notice we don't know the actual code of what's inside of there, right? We don't know what's inside of get monthly payment. There's some type of calculation that goes on inside of there based on the loan amount, the interest rate, the number of years. There's a monthly payment that will be calculated based on this stuff here. Okay, but we don't show what's inside of there at this in the class diagram. There is an activity diagram as part of UML. It's a flow chart that we can show what the inside of a method looks like using a diagram. But for a class diagram, we just show for a single class, we just show the name, the data fields, and the methods. Okay, we talked about this a little bit before. Now we're going to go a little bit deeper. Okay. Another example here. BMI class where the parameter, the data fields would be name, which is just what the person's name is, but their age, weight, and height is important. All right, for calculating BMI, body mass index. I can't remember what the Turkish for that is. All right, the idea is someone who is tall and has a low weight, is light, then they would have a low BMI. Too low and you're too skinny. You're unhealthy and on the skinny side. A BMI that's too high means that for your height, you have too much weight. And so it can be not healthy on the high side. Okay. And this would be something where we could say, these are some things that we, okay, yep. That's right. I did hear that once before, but I couldn't remember it. Okay. So this is how we might show the class, an individual class. But one thing we will want to show a lot on occasion will be how classes are related to each other. Now, there's a couple of different types of relationships, a few different types of relationships. We have the one-to-one relationship, a one-to-many relationship, and a many-to-many relationship. Okay. Now, faculty, because these slides are based on a non-Turkish textbook, faculty refers to not the faculty like you guys would think of it like the engineering faculty. Faculty means a person. It's a faculty member. So if we were, can I write on this? Let's see. So if I take this, faculty. Teacher. All right, okay. So think of it as it's a teacher, not a okay. So a teacher teaches a course, can teach 0 to 3 courses. So this could be 0, 1, 2, or 3. That's what these little dots mean. This dot means between 0 and 3 courses. Okay. A course has one teacher. Makes sense. On this side, we have a relationship. Students take courses. Now, this star means 0 to many. 0 to there is no upper limit. They can take as many courses as they want. Okay. We're not going to put a limit on there. But we might put a restriction like 5 to 60, which means no less than 5, no more than 60 students can be enrolled in a course in an example system like this. Okay. I'm going to draw out the next one though on the whiteboard because the next one, the figure is from the over time, yes, but like right now, I am, according to the OBS system, you can only have one teacher for one course in a semester. So think of this as an individual semester. But you're right. Different teachers can teach different courses over time. That's true. Let's see. Let me switch over to the whiteboard because I want to draw out the next one on the whiteboard because it's a reference back to a figure in the text that doesn't show up in the slides. So imagine that we had a class called student. And okay. And let's maybe assume there's some parameters and all that stuff. Now, let's say that instead of just saving it as a string, that we had a class called name. And maybe they might have like a first name and a last name. Something like that. So instead of saving their name as a string, just as a string, we're going to save it as a class. Okay, we're going to save it as an object that has different parts to it. Name, last name, maybe a middle name, something like that. Okay, and in the same way, we'll have the student will have an address. Okay, and there might be a street. There might be a city. There might be a mahale. What else? There might be a country. All right, all kinds of pieces to it. There might be a postal code, you know, stuff like that. Okay. Now, what type of relationship? Let me erase that just a little bit. I don't like it when it just hangs over like that. Okay. Now, the student and the name is going to have a relationship, and a student and an address will have a relationship. Right. Now, there's the three types of relationships that I talked about. We called them one-to-one, one-to-many, and many-to-many. Okay. Notice these dots are different from that side-to-side dot. So this is the general type of relationship where one of these goes to one side and one of these goes to the other side. Okay. Now, for the one side, a one type of relationship, it could be, there's two different possibilities. It could be a 0 or 1, or it could be a 1 and only 1. What's the difference between those two? The 0 or 1 says it's not required. So for example, in the slides example over here, right, we had the teacher could teach 0 to 3 courses. The teacher's not required to teach a course in a semester. Maybe they might be taking a break. Maybe they're focusing on research. You know, for whatever reason, they're not teaching any courses. This would be the not required. Okay. But in a one side of it, it's not required, but at most it can have 1. So an example in a real world situation might be a Gmail account. If I was saying, okay, I want you to have, I want to know what students, give me your Gmail account addresses. Well, some of you will have a Gmail account, you'll have only one. Well, I guess you could have more than one technically, but yeah, okay. Let's just say it identifies who you are. Well, at most you'll have 1, but you might have 0. Oh, I'll give you a better example. Something that does identify you. Something like all the people in the world. I want to have a system that tracks their Turkish, their TC kimlik numbers. Right. Well, not everyone's going to have one, so they're not required to have one. But if they do, they're only going to have 1, right? They will only have 1 if they have 1. Right? So that's what this kind of thing is. Okay. This one would mean it's required. Okay. It's required and it can only have 1. Okay. I'll explain that in a moment. So it's, well, I mean, it's pretty self-explanatory. You can only have 1. A name might be an example. In the system, in the OBS system, you have a name and you only have 1 name in our OBS system. Okay. So let's talk about that many. What are some possibilities for many? Well, there's lots of possibilities for many. Okay. You could have 0 to many, meaning it's not required, and you could have many possibilities. So an example would be back to those email accounts. You're not required to have an email, and you could have more than 1. You can have as many as you want. This is also shown as just a star on its own, okay? It could also be a star on its own. Okay. Another possibility, a one-to-many, right? A one or many. It's required that you have at least one, and you can have as many as you want. That's what these little stars mean. It's an unknown. It's just as many as you want. Okay. We could even get really fancy. Well, not really fancy. Just we'll get really fancy in a moment. We could get fancy and say, like the example back over there, you could have 0 to 3. Means it's not required, right? But at most it could be 3. It could be at most a specific number. It could be from one number up to another. So it could be you must have at least 1, but at most you can have 2. Right? Maybe like a phone number in the system. We might say, hey, we want you to have at least 1 phone number, but at most we want you to have 2. We don't want to keep track of like lots of phone numbers for you guys. Okay. We could get really, what I was saying was really fancy was we could say, well, it could be 1 or 2 or 4 or 6 possibly. All right. Where on one side of the relationship, it's required. It could have 2. It can't have 3 only. It could have 4. It can't have 5. It could have 6, and it can't have more than 6. Right? If we got really fancy, this right here, very rare. Doesn't usually happen. Okay. So the question we're coming back to this with. Okay. So a student, we would say, okay, a student must have a name. Right? So we're going to know that this is required. So this side of the relationship is 1. And the student will have how many names, do you think? How many names do you have in our OBS system? Yeah, I only have, you can have a nickname, that's true, but in terms of like tracking it in the system, you would only have 1 name. Good. Okay. Now a name object will belong, if we have a name object, and remember, we're not keeping objects of random names that don't exist in our system. We're only having names that exist in our system. A name object will belong to how many students? Right. That's what I would think also. It would be 1. All right. Because if 2 students share the same name, we probably just create a new object with the same values. We probably won't try to match that. That's saving too much memory space. Okay. All right. Now a student will have how many addresses? Right. Good point, Tanana. Let me point that out with a different color. So we would refer to this, so 1-to-1 on this side, 1-to-1 on this side, we would refer to this as a 1-to-1 relationship. Okay. This is the type of relationship, 1-to-1. This is details of the relationship. It's a 1-to-1 relationship required on both sides. So a name must have a student must have a name, and they can each only have 1 of each. Okay. What about the student and address relationship? A student will have at minimum how many addresses? Is it required that a student have an address? All right. We'll say it's required for that a student will have an address. We'll say that, sure. Or can they be homeless? Actually, Tarana, you bring up I hadn't considered that, but I think let's go with you because of something I want to show on the next slide. Let's say that a student does not require to have an address. Okay, so they're not required to have an address, but if they do, how many should we keep for them? All right. If we do have an address for them, how many should they have? And let's go with 1 on that. Right. Let's just, and you're right, Oslam, it does depend on the system. And what we can do is, this would be one of those things that if you're not sure, talk with your customer, talk with your client to determine how they want to do this. Okay. All right. If we have an address in the system, how many students will it belong to? Like what's the minimum number of students it should belong to? All right. Yeah, if we have an address, stored, we're going to have at minimum, it belongs to a student. How many students can there be at an address? Right, you might have roommates. I'm sure some of you do, right? Some of you have roommates. All right. Then there is, and we won't put a limit on this because we don't really know. We don't want to say, oh, we can only put 3, because what happens if a 4th student moves into an apartment, right? So it would be this 1 or many. Now, even though there's a many right here, well, actually, because there's a many right here, this type of relationship is this. It's a 1 on one side. It is a many on the other side. Okay, so this would be considered a 1-to-many relationship. This is a 1-to-1. This is a 1-to-many. Okay, which brings us to our slide. Let's go back to the slides. Because how do we represent it in Java? That becomes the question, right? We want to know not just how do we show it in a graphical, in a model type of thing. We want to know, how do we write the code for this, right? So what do we do? Well, a 1-to-many relationship is easy, right? A 1-to-many relationship, we'll do it like this, right? We'll put a variable for the student in the student class that points to an address object. Okay. And what happens if another student gets the same address? We just put it there, right? We just put it there. What happens if a student doesn't have an address? If it's blank or we just set it to null. All right. But this way, many student objects can have the same address. All right. We don't need to put a pointer to the student in the address thing here, right? Because there won't be more than one. Because we don't want to create. We don't have to create it both ways, right? If we want to learn what the student's address is, we'll just put it as the address object here. Okay. Now the 1-to-1 relationship can be a little bit trickier, can be a little bit different, right? Because which one do we put it in? do we put a pointer to the student for the name? Or do we put a pointer to the name in the student? Well, as we see here in this slide, what they've decided to do is they've put a name variable in the student class that points to a name object. When it comes to a one-to-one relationship, we have to do what makes the most sense, what kind of makes the most sensical thing. And you can use language, you can use a spoken language like English or Turkish to determine what kind of makes the most sense. Does it make more sense to say that a name has a student, or does it make more sense to say that a student has a name? I hope most of you think to yourself, Hojam, it makes more sense to say that a student has a name. And that's how it's represented here, right? A student, the class student, has a name object, right? Notice also it does make more sense to also say it this way. The student has an address, right? Although an address, if it's an apartment, has many students, but the one-to-many relationship, makes the most sense to put a pointer to the one object in the many side. Okay. And then that way, if a student gets added to an address, we just change this variable to point to that address, rather than trying to deal with some like array or array list over here, which would not be fun or easy. This would make more sense. Okay. Right. So that's how you would represent that relationship. Now, a trickier one is the many-to-many relationship. That one's harder to represent. Okay. Also one other thing here is we can have what's called a recursive relationship, where a person can have a supervisor. All right. Now, a person has another person as their supervisor, where we have just like in the one-to-one here, it becomes easy, person gets a supervisor. Could we do it the other way, supervisee? Yeah. Either way is possible. But if a person has a single supervisor, if it's a one-to-one on one side, a one on each side, recursive relationship, we just put a pointer to an object of that type. Okay. Now, more often than not, though, most often a person does not have a supervisor doesn't have just one person that they're supervising. I mean, look at our department. I have a supervisor. Meli Hoja is my supervisor. I am not the only person that he is supervising. All right, he's supervising lots of us all at the same time, which means his relationship with us would look more like this, right? A one-to-many recursive relationship. Or actually, in this saying, if a person has several supervisors, but let's think of it as a person is supervising multiple people. We could represent that using an array. Okay. All right. So this is how we can represent those UML relationships in a class diagram in Java. Again, I've gone ahead and introduced quite a bit of new material for you to understand. I've introduced some new UML concepts. I need you guys to know those. I need you guys to understand those because not your first assignment, but your second assignment will ask you to draw a UML diagram. Okay, so you will need to understand the UML class concepts so that you can understand how systems are related. Okay, one other thing, for chapter 10, since we're supposed to finish it off and we're also supposed to get into chapter 11 next week as well, I will probably skip ahead a bit in the slides for next week, but I do want you to go ahead and look through them, okay? So we won't cover, let's see. Where was I thinking? We'll skip ahead to the wrapper classes. We'll talk something about the wrapper classes starting next week. So we'll skip the whole stack of integers class, but go ahead and look at that and look at those examples, the stack of integers example. It's available. It should be available in the lecture examples. I don't have it up, so I thought I had it up. I guess not. Okay. So I will, I'll go ahead and if it's not there, I'll go ahead and put it up there. But the stack of integers example should be there. So just go ahead and take a look at it and see how that's implemented. But make sure you understand the UML stuff, okay? Are there any questions about today's material? We did cover a lot today. And so I'm sorry if your brains are a little bit caught a shook, but we have a lot to cover, and I want to go ahead and lay that good foundation for the stuff we cover through the rest of the semester. Okay, so the videos, I'm putting them up on the stream channel as soon as I am able. I download them here, the recordings, and upload them to the stream channel and to the YouTube channel. So you should be able to get them there. The slides should be available in the class materials folder for this course. Is anyone having difficulty accessing the slides, the slides folder for this course? What I showed last week, let me show you here. Okay, so this is what you should see. So this is what I see when I pull up the Teams. All right, so this is our Teams channel. If I go to General, all right, if I go to Files, it should be here under Class Materials. Go under Class Materials. We should see a folder called Lecture Slides. Yep. So here's the lecture examples. There should be Chapter 9 and 10. Okay. And that fall 2020 assignments. And then if you go to Lecture Slides, you should be able to see all the slides that I've uploaded here. And I will upload Chapter 11 here today or tomorrow. Okay. So that should be how you access the slides. And again, the videos should be available through the stream channel. Okay. Good. I'm glad to hear that, Tarana. Good. All right. Any other questions? All right. Have a good weekend, and I will see you guys 1 week from today.